In this task, I'm going to say some words that are the names of objects and animals. Listen carefully, and when I finish, I want you to say them back to me in the order of their physical size, so from smallest to largest. Wastebasket, oven, river, slipper, lemon.
Slipper, wastebasket, oven. Yeah, what the last one you said there? I've forgotten it already.
While only some of us suffer from strokes, all of us worry our minds may start to fail as we get older.
I'd like you to point to the same blocks in the same order. Here's the first one.
This lab at the University of Michigan studies how age affects mental performance. Its director, psychologist Denise Park, is gathering evidence that presents a new view of brain aging.
Aging begins in your 20s, as soon as you reach maturity. Our data show clearly, absolutely clearly, that as you age from 20 to 30, you're a little bit slower. You process information not quite as fast. You can hold a little bit less information in consciousness, and you recall a little tiny bit less from 20 to 30, and from 30 to 40, the same thing, and so on and so forth. Then suddenly you're 70 and you start really noticing, perhaps, that these continuous declines have aggregated. And you may realize that you're not cognitively what you used to be. Now, this is especially true of memory. And the more unfamiliar the information, the more trouble you're going to have. You're going to remember familiar stuff. But if I bring you in my lab and ask you to remember a list of words, you're going to see that age-related decline.
Okay, this task is the free recall task. In this task, I'll read you a list of 12 words. You should listen carefully to the words, and when I get to the end, you should recall them back to me in any order that you like. Okay? All right. Line, honey, train, sky, puzzle, jury, garage, doll, wife, toast, bed, watch, recall.
Line, honey, train, sky, doll, honey.
Watch, honey, train. I said that, didn't I?
Watch, toast, doll, wife, honey, line.
Learning someone's name, remembering where you parked your car.
Jury comes to mind.
Why do these things get harder as we get older? One answer may lie in the way new memories are formed. For a memory to take shape, neurons must forge electrical and chemical links that connect them into a stable circuit. For decades, scientists thought that as the brain aged, millions of neurons died, making it harder for new circuits to form. But in the 1990s, this long-standing theory was found to be wrong.
One of the most remarkable things now that we understand it is how little nerve cell loss there is, how much the brain stays full of cells that we need in order to function normally. And that's something that we didn't used to know at all.
Now this is interesting because it forces us then to look elsewhere for the changes in the brain that are impacting function. Hey guys, how's the cutting going?
Great.
Are these the brains from Boston?
Yeah.
At Mount Sinai School of Medicine in New York, neurobiologist John Morrison is looking for clues in a region of the brain where new memories are formed, the hippocampus. When we learn something new, neurons in the hippocampus forge strong connections by sending across the tiny gaps between them, called synapses. Essential to the strength of the connection is the movement of electrically charged particles of calcium drifting through the synapses. When the particles stream into a neuron, they trigger chemical changes that make the connection more reliable. The calcium flows through a molecule that's the gateway to the neuron, the NMDA receptor.
We know that the NMDA receptor is critically linked to memory. So one of the changes that leads to memory decline in aging might be lower levels of NMDA receptors. So we have looked for those kinds of changes.
When Morrison examined the hippocampus of monkeys, he found that in young animals, a single synapse had dozens of NMDA receptors. But in older monkeys, the numbers of receptors dropped sharply.
Well, it was really amazing because this decrease occurred in the circuit that leads to the ability to learn and remember new things, the classic form of memory that's affected in aging. This is, to me, an optimistic scenario because now we have a molecular target that could potentially be manipulated to restore the health of that memory circuit. You guys can start staining for the light microscopy.
Morrison is trying to develop drugs to replenish the lost receptors and rejuvenate failing memories.
So that'll give us a receptor and a presynaptic marker.
But the brain, scientists are learning, has ways to rejuvenate itself. 93-year-old Milton Adamson has exercised regularly since he was 42. On memory tests, he does as well as people half his age.
I feel that the mind does not lose its ability as quickly if you exercise.
We never used to think that physical activity was good for the brain until really very recently. And there was a large study that was done where they took over 1,000 people in the community and looked at the things that predicted what helped them maintain mental ability. And it turned out that physical activity was one of them.
Yeah, well, we'll get involved with that in the next week or so, because I just got a call today from Burns Nugent, asked me to be present at the next meeting, which is a week from Thursday.
Milton has been tested at the University of California at Irvine, where scientists are searching for the biochemical keys to successful aging.
The biggest revolution is we've gone from describing what's going wrong to getting deep down into the mechanisms to tell what can you do about it and how can you put more quality into the life of a neuron.
Carl Kottmann theorized that exercise might help to keep neurons healthy by boosting production of vital brain proteins. To test his theory, he compared two groups of rats. While one group sat idly in their cages, the other group spent hours a day running.
They jump into these running wheels and they go like gangbusters around, and they even do little tricks in the running wheels. And then you say, well, what happens to the brain now?
After 8 days, Kottmann found that in the running rats, levels of a protein that helps neurons grow, called BDNF, had doubled in a part of the brain that's critical to memory.
The surprising bottom line is that exercise will induce all kinds of wonderful molecules that keep neurons healthier, they keep them stronger. They're basically molecular fertilizer. And running actually increases these molecules in the brain.
As knowledge of the aging brain deepens, a new portrait is emerging of an organ that's resilient and resourceful, whose lifetime of experience may provide it with a unique advantage.
Younger people seek out more information, and that's what they're good at. They're good at processing and seeking information. Older people are good at mulling over situations, reflecting, and using and drawing upon their experiences.